Howdy, howdy. Welcome, welcome. We just started, so give it a minute, let some people trickle in, and we'll get started soon. I did not sleep enough today. Welcome, welcome. Hope everybody had a good day. Good morning. Morning, morning. I kind of look like Chorus here. I don't know what that is. I don't know who that is. Okay. Good morning. Howdy, howdy. I wish there was a way to get the... Because, like, the names are really big. And I wish the names were smaller. Like, of the text. But I don't know how to, like, it seems like there's so many options and I just don't know how to fix that. What if I did that? No, that's probably not what I want. Oh well, I'll think about it later. Right, let's answer some questions. What are the roundest cosmic bodies out there? Well, in some sense it's going to be... Okay, actually, if you want round, if by round you mean like smoothest, then it'll be black holes. The event horizon of a black hole is in some sense perfectly smooth. But if you want roundest, the thing is the faster something spins, the less round it'll be. And so you'd want something that's really not spinning very fast at all. It's possible that the roundest thing, like the most spherical thing, because it's not spinning, the most spherical thing, macroscopic thing, could have been created on Earth. There was a silicon sphere that's like this big, that was like, you know, perfectly spherical to within whatever tolerance. Could there be multiple equally valid formulations of physics that don't translate into one another? I guess there could be, but the thing is that if there were, then you would kind of have a built-in translation if they're equally valid, right? What's the latest news on time dilation? There's not really any news on it. Like, it's true. It's a real thing. How are your views on an oscillating universe? You'd have to give me more details on that. Why are there two measurements for the expansion of the universe? This is called the Hubble tension. We don't know. There's not currently a well-explained resolution. So not neutron stars? Well, look, I don't think that we know of any slowly rotating neutron stars. That's the issue. And so neutron stars, because they rotate so fast generally, they're going to be a little bit fatter around the waist, right? Is it possible in theory to customize matter on quantum level and give it whatever properties we want? I mean, like, you can just, that's called chemistry, basically. What percentage of physics PhDs become professors? I think I've seen the numbers like 10%. Are black holes infinitely dense or just really, really, really dense? I've heard it both ways. So we don't know. We don't know what's at the center of a black hole. It could be a singularity, but that seems to be falling out of favor. Less people are taking singularity seriously these days. So it seems likely to me that it's just something really, really dense. I feel silly asking this, but when a plane is flying, does the Earth really rotate 1,000 miles per hour underneath it? No, the plane is moving with the Earth. So it's either moving 500 miles with the Earth in one direction, or 500 miles relative to the Earth in one direction, or 500 miles relative to the Earth in the other direction, or a third direction, or whatever. It's not like the plane is stationary and the Earth is rotating underneath it. What about a drop of mercury floating weightless? Roundest? Yeah, that could be it. Definitely. But we would need to make such a thing. What do you plan on doing with the survey data on MAGA being anti-science? Nothing really. Like, I don't have any plans for it. It just seems like, I have access to a population of people who are, particularly combative because they want to debate, and so I'm just interested in what they think, and maybe I'll make something of it at some point. But why don't all negative charged electrons dive into the positively charged nucleus of an atom? Essentially, they have too much angular momentum. And momentum is conserved, so they don't really have a way that they can get close, because getting close means that their angular momentum would have to go down, and that angular momentum can't go anywhere. What's something Star Trek got right? They got flip phones right. In fact, they predicted flip phones. In fact, flip phones were inspired by Star Trek, if I remember correctly. The inventor of flip phones were inspired by the communicators from Star Trek. Would you ever work in theoretical physics if you ever got the possibility? I already do. Why is gravity not a force? Gravity is a force. What does it mean to be a physicist? Well, in some sense, being a physicist is an occupation, which means that you spend, some chunk of your day, like on a regular basis, doing it. Are virtual particles the only truly random things in the universe? Virtual particles don't really exist. How is dark matter and dark energy a proven thing if we don't know what it is? Well, look, so I wouldn't say that they're proven things. Like, we have really good reason to think that they are real, because we see the effects of, because if they existed, then the things that we observe would make a lot of sense, but we haven't proven that they exist. But there is something that's causing these anomalous effects, we just don't know what they are. If you were to be floating in space with no acceleration in any direction, would it still seem like you're flying through space since everything else is still moving? You probably wouldn't notice anything else moving. If light don't have mass, why isn't the speed of light moving at infinite speed? Because it's moving at a finite speed. I mean, look, our universe could have been a different way, where the speed of light was infinite, but it's not. It's finite. That dust analysis argument from yesterday was a thing of beauty. Well, yeah, nobody ever actually has, nobody ever refutes it. They just say, like, nah. Do you think CERN is justified in asking for a new super collider? Where do you stand? I think generally, if we increased our spending on science, that would probably make the world a better place, not a worse place. Because it means that we would have less money to spend on, the Department of Defense, or various military expenditures, or, subsidies for coal companies, whatever it might be. Or tax breaks. So, like, tax breaks for the rich. Like, I think that spending on science is generally a good thing. I don't think it's ever been bad to spend on science. What theory best explains what happens to information in a black hole? There's not really, like, there is probably a consensus that the information is not, it's not deleted, but there's not really consensus on how it's not deleted. Would you ever do a Q&A with a grade 7 and 8 science class? If somebody wanted to invite me to do that, I'd be more than happy to do it. I'm a little bit behind, sorry, I have to jump up. What is information and why is it central to decoherence? I'm not sure I would say it's central to decoherence. Information is just kind of like a way of thinking about the way that we think about. Sorry, that didn't make sense. Information is kind of just a way of thinking about entanglement. But like, entanglement is really the thing that you want to think about when you're talking about decoherence. You want to think about like how the entanglement is localized to a very small system, and then during decoherence that entanglement delocalizes. Does the observer effect play a role in particle collision at CERN? The observer effect, it's not really a thing, but no, not really. I mean, the particles that were but even if it were a thing, the particles that we're studying are so high energy that they basically behave like particles the whole time. From Miko Makapa with the £5, would you, or do you already, consider streaming to a European platform? I was under the impression that I'm streaming to international platforms. YouTube and TikTok are both available internationally, I believe. I don't know what you mean by a European platform. Dr. Blitz, can the field equations explain an accelerating expansion without the lambda parameter, or is it necessarily needed? Yeah, it basically is necessarily needed. Otherwise, you just have radiation and matter, and those cause attraction, not repulsion. What university physics courses would you recommend for someone who doesn't know? Just start from the beginning. Like if you want to learn physics, then start from the beginning. There's a standard curriculum. You'll end up taking mechanics, you'll end up taking thermodynamics and waves, you'll end up taking fluid mechanics maybe a little bit, you'll end up taking electromagnetism. Could the Big Bang be the catastrophic failure of a pressure vessel? Not really. Have you read Morin's classical mechanics book? I haven't. Well, I know physics. I'm at A level. I'm about to go to university. Oh, well, good. How does string theory connect big and little gravity? Well, string theory just basically describes gravity as the fundamental force arising from effectively a graviton. And the graviton is described by a closed loop string. And then once if you minimize the action and then you do a field expansion, what you end up finding is that the Einstein field equations are satisfied in the perturbative limit. Would you entertain the idea of a cyclical universe? Absolutely. If aliens exist, what common like human features do you think they will have? Oh, I don't know if they'll have any. Do you think learning advanced high school physics in 4 months is possible? I don't know what you mean by advanced high school physics. High school physics is generally like pretty simple, I mean, it's not simple to like high schoolers, but like it's not like quantum field theory or anything. So I'm not sure what you mean, but generally, yeah, that's like 1 semester, right? Could the Big Bang be the inside of a neutron star turning into a black hole? No. Why are there people that believe the Earth is flat? If only I knew. I mean, I could speculate, but what's the most interesting discovery in physics in the last couple of years? My view is that it's not like, it's still tentative, but it seems like dark energy is not constant. And that's going to change the way we think about the long-term evolution of our universe. How can we detect a graviton if they exist? It's not clear that it's not clear that we can. In fact, there have been papers that have been published that show that we currently have no way to distinguish between a graviton and just a small amplitude gravitational wave. Gravitons have been detected? No, they haven't. How do we know Earth is round without going to space? Well, you can measure something. If you're on the thing, then you can measure the shape of the thing. In the same way that like if you were on a triangle, you could walk around and find that you turned 3 corners before you ended up back where you started. Like then you'd know you were on a triangle, right? If the theory of relativity is right, why don't electrons radiate if they accelerate upwards? You should go watch my video on it. This is actually like really, really not agreed upon. And this is something that Feynman probably got wrong. But go watch the video, I do a deep dive into it. Star Trek loves bipeds, humanoids, but the series offers an explanation why there are so many. Yeah, no, I really appreciate that episode of TNG. The Chase, it's such a good episode. What is dark matter and dark energy? So dark matter is the proposed kind of matter that is the explanation for why we see certain gravitational phenomena that we see. For example, we see that the gravity of a galaxy is bigger than the amount of stuff that we see in the galaxy should account for. We see that the gravitational lensing, so light being bent by gravity, is more than what we should see based off of the amount of stuff that we see out there in the universe. And we see that the cosmic microwave background radiation has certain peaks in certain places that's only consistent if there was some kind of matter that doesn't interact much. So that's what dark matter is. We just don't know specifically what kind of matter it is. It's just something that interacts gravitationally. Now, dark energy is this hypothesized thing, substance, whatever, that accounts for why the universe has been expanding at an accelerated rate. And we don't know what that is. Do small black holes exist? Black holes with less than the mass of Jupiter? Not as far as we can tell. We haven't seen any, but there's no reason why they can't exist. Currently, one of the contenders for dark matter is black holes that have the mass of about an asteroid. From Mindforge Manacle, did you know Uranus is a black hole? Zing! Well, thank you for the $2 for the dumb joke, Mindforge Manacle. I appreciate it. And from Garain with the $5. What's the general consensus on quasi-stars, black hole stars in the early universe? Real or no? Explain SMBHs or no? So it seems like the evidence is, with JWST, it seems like the evidence is starting to tilt towards supermassive stars. These are closely related to quasi-stars or black hole stars, but supermassive stars are a little bit less exotic. They don't require direct collapse at the center and like some sort of accretion. It's just like a star that is super, super big. And it's just like otherwise a normal star, and then at the end of its life, it just directly collapses into a supermassive black hole seed. That seems like that's the way things are going right now. We haven't ruled out black hole stars, but the alternative, which are just supermassive stars, they in some sense require fewer assumptions. So that's kind of where people are leaning nowadays. Can dark matter be a standing gravitational wave? No, not really. Dark matter is matter, like it behaves like matter. If it exists, if we're not just like wrong about gravity, then it behaves like matter. What is charge? Some sort of geometry of the surface of the atom? Any thoughts? So charge is, it's a property. You can kind of think of the charge of something as how that thing responds to changing electromagnetic fields. That's really it. You can go a layer deeper and you can say that charge is how a thing responds to changing electromagnetic force potentials. And the electromagnetic force potential you should kind of think of as like, at least once it's gauge fixed anyway, you should kind of think of as fundamental for the universe. It's just like a fundamental object. And depending on how it's moving, it affects things in different ways. And those things can affect it in return. From First Dr. Dead with the $5, thank you so much. If explosions go outwards, how can we look back in time to see the Big Bang when light should have gone past us already? The Big Bang wasn't an explosion. Common misconception. So 13.8 billion years ago, the entire universe, meaning all of space, was smaller. And then all of space, and it was hotter too. Like the entire universe was hot. It wasn't like hot surrounded by nothingness. It was, there was just hot. Everywhere was hot 13.8 billion years ago. And then everywhere got colder and colder as things got further and further away from each other. And eventually, the universe got cold enough that it wasn't plasma, it wasn't ionized anymore, that light could pass through it. And so basically, light has been emitted from literally every single point in the universe in all directions. And so some of that light has been traveling for 13.8 billion years, and it is just now getting to us because it started off further away. From Johnson Michael with the $5, Blitz, do you believe aliens exist? I do think that they probably exist somewhere in the universe. I don't think that they've ever visited us. Our universe is just too big. Like, space is just far. Stuff is just far apart. If dark matter behaves like matter, is it something that could be put in a container? Well, I mean, in principle, yeah. But the thing is it doesn't interact with electromagnetism, as far as we can tell. If it is just some kind of matter, it doesn't interact with electromagnetism, which means that like the usual things that we can put in a container, the reason they stay in a container is because there is a force, the electromagnetic force kind of keeps them in. The electromagnetic force from like the glass walls or whatever keeps it in. Like there's electrons and they repel the other electrons and that keeps them in. But dark matter wouldn't interact with the electromagnetic force, so it would just pass right through. So we would need some other kind of container that would be able to interact with it and keep it contained in a way that it does interact with whatever force we're using. If there was no bang, what caused the expansion? We don't know what caused the expansion, but there is like probably a plurality or perhaps even a small consensus that this was caused by something called inflation. Now, inflation was a very, very rapid period of expansion where the universe was dead cold and basically empty. And it was driven by something called the inflaton field. And then, for quantum reasons, basically, the inflaton field tunnels down and it dumps its energy into all of the other fields that are present, and it heats the universe up really, really hot, and that causes the expansion. This is called this process of kind of dumping energy into the other fields and causing heating. This is called reheating. What do you think about electrons being made of self-contained photon loops? I don't think it's true because photons aren't charged. Do you think time and electrons are charged, so you can't make charged things from uncharged things, right? Do you think time existed before the Big Bang, or was it an emergent property of it? I lean towards yes, it existed beforehand, but it may not have existed at just around that time, and it may have existed before and after, but not at the Big Bang because quantum gravity stuff. Are black holes that scary? Kind of a bit scared. Not really. Like, you shouldn't be too worried. Black holes are, just think of them like really, really dense stars. Like, if you're afraid of falling into the sun, then sure, be afraid of falling into a black hole. But otherwise, don't be too worried. Have scientists been able to recreate the beginning of life from non-life, the first single cells? Well, not in full, but in many parts, yes. But also, I'm not a biologist. From Johnson Michael with the $5, Blitz, do you believe that the US government has reverse engineered UAPs, UFOs? No, I don't think that they have any. I would sooner believe that the government was staging those hearings to cover up, sightings of top secret military aircraft. And from Blur with the €10, in a debate, you defined universe as the sum total of everything in existence. Does universe, sum of existence, include multiverses? If so, what term describes the individual universes? So this is just like it's like a semantic point. And, it's one worth considering. In philosophical discussions, typically you just want to say the universe is just like all of the physical stuff that exists, right? But when we are talking about, when we're actually doing cosmology, we need a word to differentiate between if there's this idea of like bubble universes in a multiverse, and then you want to use universe to refer to each of the individual bubbles rather than like the whole thing. And that's just so that you can be more specific and, not overload your language. That's all. Could a black hole sneak up on our solar system? Yeah, I guess it could. But black holes are not that common. And, I feel like we would probably know that something was wrong. I mean, it depends on how fast it's going, of course. But we'd probably know that something was wrong long before it became dangerous for us, because we would see orbits change. Depends on how big it is and how fast it's moving, of course. Dr. Blitz, will the geodesic of a relativistic electron match that of a photon in the limit of v approaching c? Not the full space-time trajectory, but just the space trajectory? Well, I mean, yeah, like as you approach c, you're asymptotically approaching a null geodesic. That's true. You're awesome, bro. I appreciate you. Well, thank you, Johnson. I appreciate you. Hi, Blitz. My son, 19, is studying a master's at Imperial College London. Oh, that's cool. Should he do a year in industry or international exchange year as part of his course? I mean, if he wants to, like, it's not going to hurt him. Yeah, it's not going to hurt him at all, I don't think. Are we moving forward with unifying quantum theory and gravity? People are working on it. It's a hard problem. Tips on grad school applications? I'm a second year and feel overwhelmed at prospects. I only did it once, and I've never reviewed other people's grad school applications, so I can't comment on what works and what doesn't work. All I know is that there were two, there was me and there was some other, so at my university, in my physics major, me and this other guy were basically tied for top of the class, or top of the major anyway. I don't actually know that for sure, but just from like, the discussions I've had with people, like he and I definitely had the best grades. And he did better on the physics GRE than I did. And he got into many more schools that he applied to than I did. So I got into 2 of the 7 grad schools I applied to. I think he got into all of the schools he applied to. Now, he got into places like MIT and Harvard. I didn't apply to those places because I wanted to be in California. Yeah, he got into a lot of places. So even though our GPAs were identical and, we both had research experience, his physics GRE, I guess, probably put him over the edge. He did maybe 40, 50 points better than I did. I didn't really study. I probably should have. Could non-standard analysis be the key to quantum gravity? Not really, because like you don't really need the axioms of analysis are not really relevant to actually doing the gravity, right? Or to doing physics. It's just kind of a tool. Isn't gravity more of an effect of mass bending space and time rather than a force? Well, yeah, but like, so it's a curvature, absolutely. But all forces are curvatures. What's your H index? I don't know off the top of my head. It's probably not very high though, because I've only been publishing for like not even 5 years, like 4 years. Would you recommend taking the physics GRE even if it isn't required for most grad schools these days? I have no idea. Honestly, I don't know. I don't know if it'll help or hurt you. I guess you could take it, and if you get a good score, then submit it. Can you expand on why electromagnetism holds stuff in containers? My instant thought is that it's the density of the container versus stuff that keeps it falling through. Yeah, no, so density doesn't stop things from being there. So there's kind of two things happening from falling through. There's kind of two things that are happening. On the one hand, the stuff that makes up your container, like plastic or glass or whatever it is, it's made of matter, and that matter is made of nuclei, atomic nuclei, and it's made of electrons. And those electrons are on basically the edges, like it's the outside barrier or the outside edges or the outside surface of your containers. And those electrons, they're negatively charged. They don't want to be near other negatively charged things. So there's already going to be a repulsion force there. Secondly, there's an extra force that electrons don't want to be near other electrons. This is called even disregarding charge. Electrons don't want to be near other electrons because of something called the Pauli exclusion principle. Basically, you can't have two electrons in the same state. It's like a law of physics. So those two factors combined basically prevent things from passing through other things. That's basically it. Do you know how the northern lights are created? I made a video on it. Yeah, essentially you have particles from space, mostly the sun. It streams through, the solar system. Some of them get near Earth. And then because the Earth has a magnetic field and those particles are charged, they basically get shunted to the poles, both the north and south pole along the magnetic field lines. And then they smash into the particles in the upper atmosphere. And then those particles, they get ionized or they get excited, and then they release light as they're becoming, as they drop down to their ground state, as they become deionized, and that produces the northern lights. How dense does something need to be become a black hole? It's not an issue of density. You can have if you look at the density of the supermassive black hole at the center of our galaxy, I don't know it off the top of my head, so I'm going to pull it up. The density of Sagittarius A star is around 1,000,000 kilograms per cubic meter. So that's really dense. But if you look at the density of ton 618, the density of, we can just compute it. We'll just compute it. Ton 618 has an event horizon that is 1,300 AU across, and it has a mass of 66 times 66 billion solar masses, divided by sphere of radius 1,300 AU. Let's see if Wolfram Alpha can actually interpret that. Divided by, well, okay, we can just do divided by 4/3 pi 1,300 AU cubed. Okay, so ton 618 has a density of 4.2 or 4.3 grams per cubic meter. So that's less dense than air. So this is to say, black holes don't have to be particularly dense. They just have to have a lot of mass in, a sufficiently small area. From Krakowski with the $5, do you have any videos about localism versus realism? And could you give a layman's description of the two conflicting ideas? Yeah, I have a few. They'll be in my quantum mechanics playlist. So localism is just the idea that things can only influence their immediate surroundings, and that the influence travels outwards at the speed of light, that you're not going to have instantaneous effects somewhere else from something happening here. That's what locality is about. Realism is merely the idea that a given experiment has, or that a given measurable property has that property already realized whether or not you measure it. So like imagine measuring the speed of something. We would say that the speed is real if the thing has that speed whether or not you measure it, right? That's roughly the idea. And so there's a conflict between locality and realism given the Bell inequality. And this is what was shown in the 70s and 80s, and this is what the Nobel Prize in 2022 was won for, that there is a tension there in the real world. From Tinky Pixie, thank you for the 20 Australian dollars. I appreciate you. Let's get a big round of applause for Tinky Pixie in the chat, y'all. Light is generated during energy production, causing excited molecules to release energy as photons. Yeah. PhD and still trying to look smart. No life equal PhD. Countless hours for proving he is a good puppet. Maybe go take a remedial English class, because that wasn't like a complete sentence. So yeah, maybe go work on that. Does an increasing understanding of science make a decreasing belief in a creator? How are some scientists religious? Are they missing something, or are the rest of the community? Okay, so look, so we can talk about correlations. There's surely no causative effects, right? Like it's not the case, or I shouldn't say causative. There's surely no definitive effects. It's not like once you learn enough science, you definitely are never going to believe in a god. That's just not the case. There are going to be super, super brilliant scientists, and some of them are still going to believe in a creator or a god or some kind. However, what is the case is correlation. So if you go look at scientists in general across the entire, like the totality of scientists, and you take a poll, what you'll find is something like 40%, maybe 35% are atheist, and then like another 20% are not sure. They think it's like some kind of higher power, but not a god, and then the rest think in like a personal god. However, if you then go take a sample of the scientists in the National Academy of Science, which is kind of like the upper echelon elite tier scientists, this is something that, you know, you are admitted as a fellow to, you know, at the top of your career. These are going to be senior scientists who have lots of accolades and things like this. Those people are overwhelmingly likely to be non-religious. So there was a poll done, I think, in the late 90s that showed that the members of the National Academy of Sciences, this is in the US, of course, I think it was like 91% were atheist, and like only 7% believed in a god or something like this. So what we do see is that the better you get at science, it does seem like there's a correlation between that and decreasing religiosity. But we can't say that it's a definitive cause, right? Isn't that a thing from before Hawking radiation was discovered? Is it still a paradox? I'm clueless. Yeah, so the black hole information paradox was still a paradox even after Hawking radiation was proposed, because Hawking radiation is supposed to not contain any information at all. At least semi-classically it doesn't. Are black holes really hot or really, really cold, or neither? Well, as far as we can tell, black holes are very cold. Until they're tiny, then they're very hot. Is the Pauli exclusion principle the principle that governs repulsion of particles with the same charge, or is that a product of electromagnetism? That's a product of electromagnetism. You can have two neutrons. Both neutrons are both fermions. They have zero charge, and yet they still repel each other because of the Pauli exclusion principle. The most famous scientist believed in God. Well, I don't think that there's a single most famous scientist, unless you count Einstein. And Einstein, it's very debatable whether Einstein believed in a God. And Einstein is probably the most famous scientist of all time. Why are black holes cold? Well, think of it. In order for something to be hot in space, it has to give off heat. And the way that it gives off heat is by giving off light, right? Like the sun gives off infrared radiation, it gives off visible radiation, it gives off UV. All of these things are a type of electromagnetic wave or light. Black holes can't do that. Light can't escape from a black hole. Now, there is a tiny, tiny quantum effect that lets them kind of leak out light. But it's very, very slow and very, very low energy light. And so they're very, very cold. Dr. Blitz, will a rocket work in a vacuum? Absolutely, yeah. I'm still not sure why we say there's a paradox in the first place. What is paradoxical about information loss? So in order for quantum mechanics to work, information has to be preserved. That's it. What do you personally think about religious people who also believe in science? Look, by all means, like, I'm not going to tell them they don't have to, they shouldn't believe. Like, they can believe whatever they want, as long as they're not hurting anybody or, you know, voting to oppress people. I don't care. Einstein did believe in God, just probably not the type of God you're thinking of. Well, look, so God, the word God has meaning. If he believed that God was the universe, then that's just like not what most people mean by God. And so like to say that he believed in God is probably incorrect. From Simeon Urchin with the $5, could you explain the quantum eraser experiment? I've heard it proves retrocausality, but also as of late, also heard it's complete bunk. So the experiment is not complete bunk. It's a super useful experiment. It's super useful for teaching us about how entanglement works and how, you know, how quantum mechanics works more generally. However, it absolutely does not prove retrocausality. The only way that you could even interpret the experiment as proving retrocausality is if you assumed the things you were studying were classical objects. But they're not classical objects. So there's no reason to think that that would lead you to the conclusion that retrocausality is a thing. So the quantum eraser experiment, and I do have a video on this, like a fairly recent one too. The quantum eraser experiment, and more famously perhaps the delayed choice quantum eraser experiment, is merely the idea that you take a photon, you split it into two so that they're entangled, and then you pass one photon through the double slit, and then the other you go pass through to some detectors. Now, the state that the second photon is in can tell you things about which slit the first photon passed through, And so if you have that information in the second photon that is measurable, like if you do nothing to that second photon, then you can measure it and use that to determine which slit the first photon passes through. And so if you filter out the first photon detection, so the photon passes through the slit and then it hits a screen. If you filter out what you detect on the screen according to what you measure the second photon to be in, you will get two different splotches, as if it passed through one or the other. But if you instead change that second photon's behavior, if you measure it along a different axis, for example, you will lose the information about that first photon. And so if you then filter the data that you get from the second photon after measuring it along a different axis, then you find that so you filter the first photon data based off of the measurement along the different axis for the second photon, you'll find that you'll get an interference pattern. But you're not doing anything backwards. All you're doing is you have like the data on the screen doesn't change. You just have a whole bunch of data on the screen, but you're just throwing away data points depending on what the second photon tells you to do. And so if the second photon tells you to throw out some data points, you'll get two splotches next to each other. If it tells you to throw out some other data points, you'll get interference patterns. But when you add them all together, you will always get just one big splotch on the screen. And I have a more detailed video on it, but you should check that out if you want more details. Can photons have different energies? Yeah, higher frequency photons have more energy. They need to do delayed choice quantum eraser with electrons with mass with detectors further back. Why? I mean, like the delayed choice quantum eraser is pretty well understood at this point. There's not a whole lot to learn. Terrence Howard suggests 1 × 1 = 2. What do you think? He's wrong and silly. How close are we to fusion power becoming a common source of power, if ever? Well, we're not there yet at all. From Mika Makapo with the £5, US-owned TikTok and YouTube go worldwide, but so do European equivalents. Would you use these if, say, US invaded a European kingdom? Well, look, I just don't know of any European equivalents. I mean, like, I'm not opposed to it. Like, if I get a broader audience, I get a broader audience. But like, I just don't know of any. These are like the biggest platforms. I hope the US doesn't invade Denmark. Denmark. That'd be good. What does your stock portfolio look like? It's fine. I'm doing A-OK. If energy is mass times speed, what increases if photons get more energy? Energy is not mass times speed. Energy for a photon, energy is just Planck's constant times the frequency. That's it. When you were an undergrad, how did you get over the shut up and calculate approach to quantum mechanics while it's so counterintuitive? I didn't. I just shut up. I just shut it up. I just shoot up and calculated. Like, if you just think that, like, oh, when the measurements are, when you take a measurement, you get your wave function collapses and you get a stochastic result. That's it. That's just it. I just believe that, and I did my calculations. Stock portfolio in this economy? Yeah, right. But I did get fairly lucky. I had the opportunity to, get a small house while I was in grad school. And as a result, just because of housing prices, I was able to sell it for significantly more. And so significantly more. And so I was able to put away some of it for, for retirement, basically. What do you think of Chad Elliott? He's the Elliott argument guy, right? He's a coward. He's a coward who refuses to debate. From Riri, tell us, with the 5, I think those are Brazilian reals, do you have a study method? I don't have a study method. I'm really bad at studying. I'm really, really bad at it. Like when I was in college, I literally just read the textbook and then did the homework, and that was it. Are you familiar with E6 Jordan algebra and recursion? I mean, I'm familiar with E6, like the sporadic group E6, but I'm not familiar with Jordan algebra and recursion in that context. I feel like Blitz should have a wood shop in his garage. I'd rather have an electronics, like an electronic workshop, to be honest. You think a theory of gravity will be compatible with GR? Please explain warping causes gravitational acceleration. So GR is our theory of gravity right now, so it's automatically compatible with itself. But please explain time warping causes gravitational acceleration. So that's like one way to think about it. In the the low mass limit and the low speed limit, it is just true that you can approximate the space-time metric as only having a variation in the space or in the time-like component of the metric. So it just the space-time metric just looks like the Minkowski metric with a slight modification in the time piece. And so if you want to say that that is time warping, then sure. And then you can just take that metric and you can compute what is a straight path in a space-time where durations in time depend on your distance from the center. And what you find is that to maximize the amount of time that your watch ticks by, which is a way of figuring out. So when you're falling, when there's no external forces on you, this trajectory you take through space-time is the trajectory that makes your watch tick the most, right? It maximizes your proper time, and your proper time is measured by a wristwatch that's falling with you. And so what you find is that if you're just sitting still in space-time and then you let go, what you'll find is that a trajectory that just keeps you there will have your watch tick more slowly than a trajectory that would have you fall in. That's it. That's the whole thing. You can just work out the math, and that's the consequence that you get. And that's roughly because the length of a duration changes with distance from the center of the gravitational force, or the center of the gravitational mass. I watched your debate with Nathan. Is he okay? No, he had he was arrested for harassing children with flat earth stuff. He is not okay. When will you debate Q-Top? I've debated him several times. I figured you already had an electronics workshop. No, I haven't had one since college. Why don't you glow the way you do on Unapologetic? I only glow that way because I can't use my own green screen. I have to use like the built-in green screen on Video Ninja. What's your opinion on weakening dark energy? I think it's one of the greatest, or one of the biggest breakthroughs of the last decade. One of the biggest discoveries. Could dark matter or dark energy be related to ghosts? I would say not. I wish Blitz would play KSP. I think that would be fun to watch. I played KSP so much. I have literally thousands of hours in that game. I played it so much as an undergrad. And not only that, I actually set a record at the time for the largest. I set a record for the most efficient rocket to get to the most efficient, this is payload mass to launch mass, to get a payload to low Kerbal orbit that was over 30,000 tons. Actually, it was over 1,000 tons even. Like I blew the record out of the water. I was able to launch like 10,000 tons, I think, with like a 33,000 ton rocket, something like that. I was very proud of it. What do you do for work? Are you a teacher, or do you apply your knowledge for a career job? You have a lot of knowledge. So currently, my career, or my job, I don't know if this is a career, is I'm making educational content on TikTok, and I do debates too, on TikTok and YouTube, of course. That's what's currently paying the bills. I did apply for some university positions. We'll hear back in a few months, or probably in about a month, whether or not I get any of them. Currently, the science communication gig gives me more academic freedom. I can do more of my own research at my own leisure than working at a university would. And so unless the offer that I get is really, really good, I probably won't take it. There's a few jobs that I definitely would take. But unless I get one of those, I'll probably keep doing what I'm doing because I make more money this way and I have more freedom. Like I'm not beholden to grants. I don't have to worry about like applying for grants all the time. I don't have to worry about like, grading exams. I can work on whatever research suits my fancy. So it's a good gig right now. And I get my teaching fill doing this. How would the existence of negative mass theoretically affect the universe? It would probably break it, to be honest. Like, it would probably break it. Think about this. There's a runaway mass problem. It depends on what kind of mass we're talking about when we say negative mass, but there's one way in which positive mass would be attracted by negative mass gravitationally, but negative mass would be repelled by positive mass gravitationally. So what you'd end up with is negative mass being chased by positive mass, accelerating forever. And that'd be really, really confusing, and that'd probably break our universe. Would you have to relocate? It depends. It depends on the job. There's one job that I'd probably be willing to relocate for. So maybe two jobs that I'd probably be willing to relocate for. And if I get them, then that's a big deal. But, have you ever sought individual grant funds? I kind of set one up myself. And this is just a good time to chill for myself. So I have a Patreon account, of course. If you're a content creator, you have a Patreon account. But one of the things that I currently get, I get donations for, and I get, ad revenue from YouTube and TikTok, whatever. That's for the science content. I currently don't have any revenue from the research that I do. So what I did is I added a super top tier Patreon level called the Medici tier, inspired by like the ancient Medici or the Renaissance Medici family of the Renaissance in Italy. So the Medici family funded Galileo's work. They basically gave him a whole bunch of money and said, hey, as long as you acknowledge us and thank us and do what we ask you to, and do the kind of things that's interesting to us, we will give you money. We'll support you. So I've added a Medici tier to my Patreon for only those people who are exceptionally wealthy and have a whole bunch of money that they want to throw away at this kind of thing. It's exceptionally expensive. And basically, what this means is it will fund my research specifically. It's not for content, it's for research. So you'll get acknowledgements in any research papers I publish while you're supporting me. You'll get quarterly updates and private Q&As, and there's things like that. So this is something that is available for people if they want to actually support research privately rather than having to go through some public institution or something like that. Of course, there's no obligation there, but it's an option because somebody suggested that it'd probably be a good idea. So that's currently how I'm funding my research with grants. Personal grants in some sense, right? Is your hair slicked back in ponytail or just no, it's ponytail. All right, let's answer some more questions. Is expanding space a similar concept to the gods of antiquity? Do you believe in its existence? Why? No, one has evidence and the other doesn't. Wouldn't positive and negative mass chasing one another violate the laws of thermodynamics? Yeah, kinda. Negative mass ruins so many things if it exists. Why does the universe exhibit chirality? What would be the consequences if it was a 50-50 split? When you say chirality, what do you mean? Do you mean specifically chiral particles? Or do you mean because we have left-handed neutrinos and we don't have any right-handed neutrinos, and the weak nuclear force only interacts with left-handed stuff? Or do you mean chirality in the biological sense? Because the former it's what makes the weak nuclear force a chiral theory, and it's one of the interesting features of the weak nuclear force. If you mean the latter, like biology, I don't know. That's not my stuff. From Bacon and Bush with the $20. Thank you so much, Bacon and Bush. I appreciate you. Here's a little to help out the science communication gig. Would it be safe to say that there is empty space analogous to outer space between the air molecules, which is why it can move so freely? Bad phrasing as usual. Yeah, in a sense. Yeah, absolutely. Yes. The distance, and it really depends. I think that, like, you can calculate the average distance between a pair of air molecules, and it's like not very far, but it's not so far. Why would positive mass be attracted to negative mass? Well, so it depends. It depends on what kind of mass there is. So there's gravitational mass, and then there's inertial mass. And so depending on what kind of, like which one's positive and which one's negative, it really changes what we're talking about here. So if we have negative gravitational mass, then in principle that should probably repel positive gravitational mass. But if we have negative inertial mass, but positive gravitational mass, then it would attract positive mass, but it'd be repelled by positive mass. Very weird. Do you believe the universe as a whole is spinning? I think it's like possible, but we currently don't have any compelling evidence that supports it in my view, so. Can you explain color charge and spin like I'm a dummy? So these are different things. Color charge, you can think of it as just like electric charge, but there's 3 of them. So rather than having positive and negative, you have red and anti-red, blue and anti-blue, and green and anti-green. And that's it. Like that's roughly the story. The only extra caveat is that so positive wants to attract negative in the same way that red wants to attract anti-red. However, red can also attract blue and green. So you can kind of neutralize positive charge. You can neutralize positive charge with in electromagnetism with negative charge, but you can also neutralize like a red color charge with 2 other color charges that aren't anti-color charges. So it's like red, blue, and green together make neutral, make white, or red and anti-red make white. And we say like white being neutral, like that's a color theory thing, right? So that's the idea. Spin, on the other hand, is just intrinsic angular momentum. A particle isn't spinning, but there's nothing saying it can't have angular momentum. And in fact, this is one of the properties of a particle. The way that we characterize the way a particle is we characterize it by its charges, its mass, and its angular momentum. Sorry, I have to drink some water. Can 100% frictionless materials be useful? Well, I don't think that you can make them. I mean, I guess you kind of can. Superfluid helium flows frictionlessly. But aside from that, I don't think that there's much that you can do. What actually is the Higgs boson? So first I need to explain the Higgs field. Higgs field, it's like a field. Like think of the electromagnetic field, which just tells you how strong the electromagnetic force is everywhere. The Higgs field tells you how strong the Higgs field is everywhere. That's what it is. It permeates all of space and time. It has a value everywhere, even when it's turned off, even when there's nothing going on. The Higgs field has something called a vacuum expectation value, meaning that the Higgs field is never 0. It's always some value. It has a certain amount of energy in it. Well, I don't want to say that. The field takes on a value. I'll put it that way. And it happens to be because that field takes on a value, even when there's nothing going on, the particles that interact with the Higgs field, which is basically all of them except gluons and photons, they behave like they have mass. They basically gain an extra little bit of mass by interacting with the Higgs field that is non-zero everywhere. Now, the Higgs boson is just what happens when you dump some energy into the Higgs field and it pops out a particle. That's all. Why quantum mechanics likely lead to any, will quantum mechanics likely lead to any practical invention other than nuclear fusion? Quantum mechanics, understanding quantum mechanics is how we have GPS. It's how we have literally every computer chip that's around you. Oh, that hurt. It's how we have MRIs. It's how we have lasers, like, yeah, quantum mechanics is like the backbone of modern technology. Is this a record video? No. Can a perpetual motion machine be made using supercooled helium? Probably not. Overeducated, it's flat. When people say overeducated, it's always like a self-own, because it just means that they're undereducated. Could black holes be pieces of mass that are accelerating so fast light can't catch up or escape? No, no. Black holes are just a whole bunch of mass in a small area. And how has our world improved because of knowing all of that? Tell me, genius. About the Higgs boson? Oh, well, I mean, like, that hasn't really affected the way that we understand the world. Or that hasn't affected, like, technology or stuff. But it has improved our understanding of the world around us, which I think is, you know, worthy. I think it's a worthy pursuit. I want to do physics for a university, but I'm low-key scared of the harder maths. Should I go for it? Look, so it is true. Physics is taught in the language of mathematics. So you're going to need to be fluent. That said, like any language, you can learn to speak mathematics. So what I would suggest is do it. And, you know, the summer before, or even, you know, as much as you can before, start grinding out your math sets. Build up your intuition so you become fluent. And then you'll have a really easy time. You'll coast. How do you feel about flat earthers? They are very misguided. Why string theory is infamous nowadays? It's not really. I mean, like, it is in the public eye because people like Sabine Hossenfelder and what's his name? There's another guy, but mostly Sabine Hossenfelder has a large platform and has like just repeatedly, like, you know, dunked on it or whatever. But it doesn't really have a bad reputation. These are small like string theorists are a small subset of theoretical physicists, and they do good work. Jump down to the bottom. We have a super chat. From RBO, why is quantum mechanics linear? What physical principle actually forces the Schrodinger equation to be linear? That's like asking why are the laws of physics the way they are? Like, just seems that that's the way. Like, as far as I can, like, the Schrodinger equation is not really something you can derive. I mean, like, you kind of sort of can from like symplectic geometry, but then like, why does quantum mechanics obey symplectic geometry? Like, who knows? This is a question for this perhaps isn't a question that has an answer. Is it true there's no reality, only probability, and technically no real such thing as solid matter? No, that's not true. At least we have no reason to think that that's true. That's a bastardization of the 2022 Nobel Prize, which like doesn't say that at all. Is the visible universe in all directions 14 billion years old? Big, or is it more flat? So the observable universe is 13.8 billion years old or so. You know, plus or minus, you know, these numbers can get adjusted as we improve our models, but it's roughly 13.8, 14 billion years old, whatever. However, if you were to ask, where are the things? How far away are the things that we're seeing now? Those things are like, at most, they can be 46.5 billion light years away from us. But we're not seeing them now, we're seeing them as they were when they were much closer. How is it that a particle appears to be in more than one place at once? Because a particle is not like a little billiard ball, right? It's not like a little classical object. It's like an excitation of a field. Think of like just having two waves that are going in different directions. That's a closer analogy to what a particle is than like a little billiard ball. Thoughts on neutron hybrid quark phase neutron star classification via machine learning? I mean, go for it. Don't we keep finding older and older stuff though? we keep finding older and older galaxies, but none of them are older than 13.8 billion years old. What's your favorite equation? Aesthetics only? It's the Einstein field equations. Particles don't have shape? No. At least fundamental particles don't. How does something come from nothing? I don't think it did. What's your stance on magnetic monopole as first state before the Big Bang, fields enclosed in a monopole? I don't think that that's like a current theory that's been proposed. I haven't heard of that anyway. What happens when matter, antimatter annihilate? Just a release of non-particle energy? It's a release of photons, which are particles. Do you think antiparticles might travel backward through time? No. No, they travel forward through time. They're just antiparticles. Can an expanding universe end in a finite thermodynamic state without ending in finite time? Yes, technically. You could have a universe that's finite, that asymptotes towards a finite volume. So like, for example, you can have a compact universe without boundaries. This would be like S3 would be the appropriate model for the spatial configuration. And it's at least in principle possible that you could have it asymptotically approach a finite volume and then just end there. It would just approach this finite volume. And so it would be in a finite thermodynamic state. And it would live on forever because it would asymptotically approach that state. Can a photon be converted back into matter? Yes, but it's really hard. From Jennifer Dennison with the $5, I've heard that the sun could emit a coronal mass ejection that will raise the collective consciousness. Can light do that? No. This is pseudoscientific pseudoscientific woo. You have a PhD in physics, so you are the one who do not understand quantum mechanics properly, right? I have a pretty good understanding of quantum mechanics. What is statistical physics most used for nowadays? Like so many things. Statistical physics is like, so we do statistical quantum physics is what a lot of people do, but like basically all of condensed matter is that. Magnetic fields curl. Magnetic field is the curl of a vector potential roughly. You can't have monopole. That's only true if you believe the Maxwell field equations, or the Maxwell equations, are complete. But you can modify the Maxwell equations to allow for magnetic monopoles. Like it doesn't take much to modify them. Can you talk about Cloud 9? I haven't, I read a Reddit thing about it. I haven't read the paper yet, so I can't talk about it now. Do you think dark matter is real? If so, what your best guess on what it is? I think it probably is real. I think it's probably some kind of heavy particle that doesn't interact with electromagnetism and probably may not even interact with the weak nuclear force. I find it weird that from seemingly messy fundamentals, quantum mechanics emerge simple macroscopic features and behaviors like Newtonian gravity, temperature, billiard balls. Thoughts? The thing is that quantum mechanics is only messy when you don't take averages. But once you take averages, quantum mechanics becomes very simple very quickly. Like there's energy conservation in the normal way. This is called the virial theorem. So like, yeah, all of this, like there's momentum conservation in the usual way. Things travel in like collective bunches. These are called coherent states. So like, it's only when you look at like individual particles that things are messy. Once you allow averages, that messiness averages away. From Yowza with the $2, do you believe there is intelligent alien life? Yes, but I don't think that we visited it. Or that it's visited us, I'm sorry. Oh. If particles are quantized excitations in a quantum field, are virtual particles just temporary excitations below the minimum and are, in a sense, real? No. Virtual particles are non-particulate, or virtual particles are a decomposition, so it's a mathematical splitting of non-particle field states. So for example, a good example of this would be, take an electric field, just a static electric field that's like a static electric field that's constant in magnitude and direction, say. That is a non-zero electromagnetic field configuration, but it doesn't correspond to any real photons. But what you can do is you can take that electromagnetic field configuration and you can write it as the sum of infinitely many virtual particles, virtual photons. But all the virtual photons are doing is it's translating a non-particle field configuration into a language that particle physicists can use in their calculation, but it's just a math trick. Why did Einstein dislike the quantum theory so much? Something God does not play dice with the universe. Also, it seemed like it violated locality, which he was quite fond of. If big heavy planets change the frequency of light, where does the energy go? I mean, it becomes gravitational potential. So like the light loses gravitational, or the light's gravitational potential energy decreases and its energy increases. Or if it emits light, the light started off with less gravitational potential energy, and as it got further away, it gained gravitational potential energy. Can you explain the parallax method and how we accurately depict the distance of stars from the Earth? Yeah, one sec. So, first thing is we need to figure out how far the sun is from the Earth. This isn't so hard. Essentially, what we can do is just using kind of like standard laws of physics, like Newton's laws of physics and Kepler's laws of motion. We can figure out, if we know the distance from the Earth to Venus, then we can figure out the distance from the Earth to the sun. That's not so hard. So we could just bounce a radio wave off of Venus and use radar to figure out how far away Venus is nowadays. There are other ways that you can do it. You can use like eclipses and, not eclipses. You could use like transits of Venus. As Venus crosses the sky, viewing it from different places, you'll see that it takes a different amount of time to cross the sun, and then you can figure out the distance from there. But setting that aside, once you know how far away the Earth is from the sun, now you know that the Earth moves 186 million miles between June and January. Or June and December, I guess. And if you know that the Earth, if you know that you're looking at a star, say up here, and you know the Earth is here in June, and it's here in December, then the distance to the star will affect how much the angle changes, because, you know, in June you're pointing this direction, in December you're pointing this direction to look at the same star. And those angles will be informed by how far away it is, because you know how much distance you've covered. So it's basically trigonometry. And then you can basically use that to figure out how far away nearby stars are, because you have a baseline of 186 million miles. From Kitnish with the $5, thank you for the donation, Kitnish. I appreciate it. Let me double check something really quick. We do have a new $5 Patreon member. Ian, thank you so much for becoming a $5 Patreon member. You now have access to my debate notes, by the way, which are accessible on Patreon if you become a Patreon member at any level, or they're also accessible if you become a YouTube member, which is like $4 or $5 a month. Welcome. Hey, Dr. Blitz, what do you know about chemtrails? Well, so contrails are a thing. Chemtrails, not really a thing as far as I know. No, not the Ian, no. Just a different Ian. Do all physicists love trigonometry? Trigonometry is like pretty critical for like physics, yeah. If dimensions can fluctuate at quantum scales, is space itself not fundamental? We don't really have good reason to think that dimensions can fluctuate at quantum scales. What is quantum gravity? Quantum gravity is, it's like a catch-all term for whatever theory we will eventually produce, hopefully we will eventually produce, that explains how gravity works at a quantum scale while reproducing Einsteinian gravity at the macro scale. If info can never be destroyed, what does that imply about the final fate of everything that exists? So the claim is that if it can't be destroyed, it can be spread out. And as you spread it out, it gets less and less interesting. From RBO with the $5, if information gets destroyed in a black hole, how can properties like mass spin and charge survive? Information is not like information here that we're talking about is information in the quantum sense, which is just basically a complete accounting of the, you know, of the wave function in some sense. It's not like just like individual numbers or things like that. And the point is that the details of the wave function are lost, but a few details are preserved, like mass. Is the rate of the universe's expansion greater than constant c? No, the universe doesn't expand at a speed, so you can't compare a speed to an expansion rate. An expansion rate has units of hertz, as in it roughly, like, it compares to like a doubling time. So you're making a category error with that question, but it's a good question. Are academic physicists upset when other physicists go into things like finance? I don't think they're upset. I'm not upset. Do what you want. Is dark matter expanding? Dark matter is I mean, like some of it, some dark matter is expanding away from other dark matter. So like the dark matter surrounding our galaxy is expanding away from the dark matter in like some distant galaxy. But the dark matter itself isn't expanding. It's just doing the same stuff that galaxies do. If Hartle-Hawking is true, is there a tiny region of timeless space out there? No, it would have all become regular spacetime. Any thoughts on the amplitude-hedron? So I don't understand it well enough to have good comments on it. I happen to know some people who do know it very well, but it's very, very quantum field theory stuff, and I try to stay away from quantum field theory as much as I can. If space-time is expanding, why don't bound systems like atom solar systems? So space-time isn't expanding, space is expanding. And roughly the reason is that the expansion force, it's just too weak, right? It doesn't have an effect on those things. It would be like, imagine that, yeah, imagine that, like, so imagine the moon is orbiting the Earth, right? It's orbiting the Earth at a certain rate, and it has a certain amount of energy tied up in its gravitational potential energy and its kinetic energy. Now imagine that you just like touch it with your finger, like just nudge the moon, just like a very light touch. Well, it's not going to affect the motion of the moon, right? That's what the expansion of space, that's like the strength of the expansion of space. So it's just not strong enough. Why avoid QFT? Because I like relativity more. QFT is messy, complicated, and confusing. You say expansion force. What drives the force? Dark energy. So, I mean, there's two pieces. There's one piece just comes from inertia, right? But then there's also a dark energy bit that is causing an accelerated expansion. At least that's the idea. Space-time isn't expanding? No. No, space is expanding in time. Like a given chunk of space is getting bigger as time goes on. But the space-time itself can't expand because expansion is a process that happens in time. From Yowza with the $2, what's your take on intelligent design? It's pseudoscience. It's pseudoscience masquerading as real science when in reality it's just religion. And it shouldn't be taught in schools. How do you visualize points of space expanding in a universe without boundary? Well, the points don't expand. It's the regions that expand. And look, the point is that if you nailed down 2 points in space, the distance between them is going to get bigger over time. That's it. Modern physics seems compatible with eternalism, the idea that past, present, and future all exist. Do you personally find that view convincing, or do you feel more aligned with presentism? I'm more aligned with eternalism. I think that this is probably more in line with relativity too. Do we know that dark energy exists to cause this idea expansion, or is it just an idea? Dark energy is just the name that we give to whatever is causing or whatever has caused the accelerated expansion. It's just the name to whatever is the cause of it, whatever it might be. Does inflation explain isotropy, or does it presuppose it in a less obvious form? It does in some sense explain it. The idea is that, you know, if you have something that's non-isotropic initially, and then you just blow it up, you expand it like, you know, by a factor of a trillion, then it'll look isotropic. Each individual chunk will look isotropic because you've just smeared it out so much. So are virtual particles real? Not in my view. Can you explain Maxwell's equations? Yeah, so Maxwell's equations are roughly the idea that, so Maxwell's equations tell you what the electric and magnetic fields look like given some charges. So the idea is that if you have a charge that's not moving, electric fields go out from it and no magnetic fields are made. If you have a charge that is moving, you still have electric fields that go out from it in a more complicated way, but now magnetic fields go around it. Magnetic fields can never go out on their own. However, electric fields can spiral if your magnetic field is changing in a particular way. That's the entirety of Maxwell's equations, basically. Also, the spiraling of the magnetic field not only is caused by the motion of a charge, but it also gets a contribution from the changing of the electric field. That's the whole thing. I shouldn't say spiraling, I should say like curling. That's probably the right word. Is dark matter considered a physical particle since it does not emit, reflect, or other than gravity interact with anything that can identify it? Well, if it is a particle, it's a particle, right? We don't know if it's a particle yet, but it might be. Will you make a video on virtual particles? I already have, a long time ago. What is your take on why gravity doesn't mathematically add up compared to the other three forces? There's a basic premise that we can use, or a basic kind of algorithm that we can use to take a classical theory, like electromagnetism, and convert it to a quantum theory. And it doesn't always work. There are theories that are so-called non-renormalizable. It turns out that the other three forces are renormalizable just because of the way that they behave. Gravity is non-renormalizable. The algorithm doesn't work when you try to apply it. You get infinities blowing up everywhere. And that's just because of the way that gravity is. Gravity is in some sense maximally non-linear, whereas the other theories are at least linear to some degree. And so that probably is one of the causes for why gravity is so poorly behaved. By the way, while I'm here, I should remind you guys that if you're 18 years or older, you should go join the Discord server. It's discord.gg/drblitz, Dr. Blitz. It's a place where you can ask me questions, you can talk to like-minded people, you can communicate with the TikTokers if you're on YouTube, or vice versa. If you're on TikTok, you can talk with the YouTubers. The YouTubers can talk with the TikTokers. It's a great place to be. You guys should go join. And if you want to support the live stream, if you want access to my debate notes, if you want access to emojis, consider becoming a member on YouTube. It's probably the best deal that you're going to get. It's like $4 or $5 a month, depending on which one you subscribe to. You get access to emojis, which are the same across YouTube channels, and you get access to my debate notes, which are, ever updating. So consider it. Or don't, but it's a nice way to support the channel. From Garain with the $5, could you explain the non-virtual particle reasoning for Hawking radiation, something related to the size of the event horizon? Yeah, I made a video on this a while ago, but essentially you just want to think of, you have fields that are not, they're not empty, they don't have nothing going on. The ground state has some amount of energy, not zero amount of energy. This is the whole business behind 0 point energy, and that energy can be realized as waves crossing over each other. And some of those waves, inside a black hole, all of those waves, they want to kind of go towards the center of the black hole, and they're classically forbidden from leaving the black hole. However, you can treat the event horizon as a potential barrier, and the waves can tunnel out, and you end up with radiation. Now you might say that the waves are really, that the waves are, virtual particles, but really you can just think of it as the 0 point energy stuff that's happening in the black hole can tunnel out. That's like a way to think about it. From Next with the $5, is it true that everything you can think or say about electromagnetism can be explained by 4 simple equations? I heard this in a Brian Greene doc, FYI. No, not quite. You need a few more. Okay, it depends. So if we're talking classically, then you need Maxwell's equations, which are the 4 equations, and then you need some rule to explain, which is 1 extra equation, to explain how charged things interact with the electromagnetic field. Otherwise, you don't really have a complete system that you can solve, because the charged things produce the electromagnetic field, and the electromagnetic field can affect the charged things, so you need to kind of solve them jointly. So maybe 5 equations. If you want to do quantum, though, in some sense, you just need 1. From Tales of the Levant with the $5, does CMB theory debunk an eternal universe? No. No, the CMB just says that the universe, that 13.8 billion years ago, the universe was very small, very hot, and very dense. That's all. That doesn't mean that there wasn't more stuff before that. Does current measurement create cosmic history, or does reality exist without an observer? That's a philosophical question. Go bother the philosophers. Can two objects become so far apart that they can never interact with each other again? Yeah, sure. Lambda is not a thing after dark energy weakening by time. Yeah, that's true. Lambda, I mean, like, it's still tentative, like it's not mainstream consensus, but yeah, that's the idea. Is it true that you love kitties? It is true. How can you summarize the Lagrangian standard model to someone who is just starting physics? Oh, you can't. There's, like, it's just a formula. Like, there's not, it won't be meaningful unless, like, you know what a Lagrangian is, unless you know what a field is, unless you know, like, it just won't be meaningful, right? What do you think about the information paradox in the case of Hawking radiation? I think that it's generally accepted that it's resolved in favor of information being preserved by Hawking radiation. What are you sipping on? It's just water. Can spacetime possibly be a Calabi-Yau manifold? So a Calabi-Yau manifold is a manifold that has an SUN holonomy, and it has a vanishing. Hold on, I'm just trying to make sure I remember before I type anything in to make sure that I get the definition right. It needs an SUN holonomy, and it needs to be Einstein. Let me just double check that I got that right. And by Einstein, I mean vacuum Einstein. So definition, here we go. It has a Kähler metric with local holonomy contained in SUN. So that may or may not be true about our universe. It's almost certainly not true. But our universe does not have vanishing Ricci curvature. Absolutely doesn't, because there's matter. And so, I mean, in principle, space-time can be, but our universe can't be. And okay, I guess a Calabi-Yau manifold is supposed to be a spatial thing, so you could probably come up with an alternative definition, like a pseudo Calabi-Yau manifold, where it would have a time component as well. But Calabi-Yau manifolds are typically space-like, or are kind of definitionally space-like. So not really. Not if you want to be strict about it. Why is there so much antimatter compared to matter? Oh, there's not much antimatter compared to matter. There's very little antimatter compared to matter, in fact. Now, why that's the case is a very hard question that nobody knows the answer to. What is your favorite commander deck? And do you think you could ever get Justin, Ian, and one other into a pod for video? That'd be lovely. I know exactly who I would. I would get Jim LePage. He's a friend of mine. I would love to get that pod going, but I don't think either of them are dorky enough to join. My favorite commander deck, I've had an Animar deck, which is like high power, you know, not quite CDH, and it probably needs to be modified to make it better. But I've had a pretty high power Animar deck for a long time, like since like 2014 or whatever. There's a special place in my heart for an Animar deck. However, the deck I built most recently, I've fully proxied, is a Grathama worm deck. It doesn't use worms, it only uses Grathama to just draw a billion cards, and that's a delight. I love playing that deck. Why are fusion plasmas so unstable? Like, with a strong enough magnetic field, would it stabilize? That's the question. This is really, like, plasma physics is really complicated. Do you play any instruments? I used to play guitar. I haven't played guitar in a long time. There's only so much time in the day, right? Did gas burn in a vacuum? No. I mean, like, you can have like pre-oxidized fuel that you can burn in a vacuum, like a firearm works in a vacuum because black powder carries the oxidizer, or gunpowder carries the oxidizer with it. But like, if you just have like hydrogen, it can't burn if there's no oxygen present. Did you enjoy the three-body problem? Never watched it, never read it. Is it possible the universe is spinning rather than expanding on the larger scales? Not really. It's definitely expanding. Now, it might also be spinning, but there's not super compelling evidence that says that that's the case. How do we age the universe? Especially interested in how far we can see versus what's beyond us versus behind. So we age the universe basically using models. So we look at the expansion rate of the universe, and we can look back through time, how the expansion rate has changed through time, and we can then use that to create a model that then tells us, we then have a mathematical formula for how the expansion of the universe has behaved over time, and then we can just wind the clock back in the model until we get to zero size, and that gives us 13.8 billion years or so. Will you explain how scientists captured light and turned it into a liquid? They didn't. That was bad reporting. From Till the End with the $5, how do you explain the UAP phenomenon known as the tic-tac, which appears to be transmedium and have no sign of visual propulsion? I think NASA actually reviewed that, and they were like, it was like a bag or something like that. But yeah, generally, I think that like, generally my view is that unless you're going to make, unless you can actually like show the evidence that this is something like real and it's something that's like actually breaking known laws of physics, I'm going to be very, very skeptical of any claims like that. Like actually like show us the stuff, show us the thing that is breaking the laws of physics, not just video, right? Just like show us the actual thing. Are we close to reaching the limit of what we can understand, an epistemological boundary? Then what? I don't think so. If the universe is expanding, what is it expanding into? Doesn't there need to be something that contains the expansion? No. You're thinking of an expansion of something within the universe. The universe itself is all of space, and that's the thing that's doing the expanding. There's just more space over time. A bag, ha ha ha, bro, no way you believe that. There was an analysis, and NASA found that like, you know, some large fraction of like these UAPs were like either birds or like piece of trash or like bags or, you know, things like that. And it may have been the Tic Tac was one of the ones that it confirmed was a bag, but I don't remember. Maybe it wasn't the Tic Tac one. Do physicists axiomatize physics? Some do. My stomach is gurgling. From Kellen Viray with the 2 Canuck bucks. Can you tell me something I should know? You should know that quantum physics isn't magic. It's not spiritual, not magic. It's statistics. What shape is the universe? Depends on what you mean by shape. But if you mean by like, if you take a moment of time, you slice the universe to that moment in time and then ask what three-dimensional shape is the universe? Well, it could be that it's infinite in all directions and it's spatially flat in the sense that like there's no curvature built into the universe. It could be that it's like the surface of a hypersphere. So like the surface of a three-dimensional ball is a two-dimensional sphere. So the surface of a four-dimensional ball would be a three-dimensional sphere. In that like you can go one way and come out the other way, and that it has certain topology and things like this. It could also be like it's a Pac-Man universe. Like you go out one way and you come back the other side, but there's no curvature. We don't know. But what the data seems to indicate is that it's if it is one of these universes that has like you can go out one side and come back the other side, then it's very, very big. In the same way that the Earth looks flat because the Earth is big, the universe looks flat because the universe is big. Do we know how long the period of the universe that was just hot plasma lasted before matter formed? Yeah, it was like 375,000 years or so. With the origin before of the universe unexplained, could it be that a temporary form of physics that could only exist then be responsible and give way to current physics? Well, it wouldn't be a temporary form of physics. It just might be a form of physics that's only applicable to like extremely hot temperatures, whatever. Did stuff spread in 360 degrees after the Big Bang? I keep hearing people say it's a flat plane and I got confused. It's not like there was a Big Bang and there's nothing around it and then stuff filled that space. All of space was just smaller and hotter, and then all of space became less small and less hot. Does the curvature of space around the Earth make pi ever so slightly wrong? Yeah, but it's probably not measurable. Is there a hypothetical end to the matter in our universe? Like if you traveled in one direction long enough, you'd get to a point where there's nothing? Well, as long as you're traveling slower than the speed of light, then no. However, it's like if you imagine that you could travel faster than the speed of light, still no. There's no, as it stands, there's no reason to think that there's places with matter, and then there's places with just no matter. Like there's matter here, so we have good reason to think that there's matter everywhere. Are you guys hearing that? I promise it's really not that bad. I'll be okay. It's not gas, I'm just hungry. And I'll grab a snack in a few minutes, it's fine. I promise. From Mindforge Manacle, is it true, thank you for the $5 by the way, is it true that quantum objects lack a meaningful notion of identity? No, they have a meaningful notion of identity. It's just they're identical to other quantum objects of the same kind. Right? So like you can have two different things that are identical in every way, except they're in different places, for example. Is it true that the reason for Ian not streaming is that you've consumed him and his logical powers to grow stronger? Yes, that is true. Where did the smaller and hotter space come from before the Big Bang? We don't know. It's an open question. My dude spends more time on TikTok than he does on physics. No, it's actually about equal. It's about 5 hours on physics every day during the weekday anyway. I try not to do physics or really any work during the weekend. And then it's like depending on the day, it could be like 4 to 5 hours, or maybe 4 to 6 hours on like making videos. Depends on how much research I have to do to make videos and then live stream. In distant receding galaxies, does relativity add a demonstrable amount of lifetime to the stars in that galaxy? From our perspective, sure. There is a thing called cosmological time dilation, but it only looks like this. From its perspective, it lives the same amount of time. The point is that because it's expanding, like imagine that a star sent out a pulse every one of its seconds, right? Well, because it's expanding, the gap between us, or the gap between the pulses that we receive from it, is longer than a second. So if it lives 10 trillion pulses long, and that would be 10 trillion seconds for the star, it would be longer than 10 trillion seconds for us, because the gap between the pulses would be more than a second. Why the fastest thing in the universe can't escape a black hole? Well, because that's what a black hole is. There's like, okay, it's the fastest thing in the universe. It's still not fast enough. Do you like streaming on TikTok? I do. Did we land on the moon? Of course we did. But do things escape? But things do escape. We can see the X-ray coming from it or whatever that is. No, so things can escape from the accretion disk around a black hole. But that's not the event. That's not beyond the event horizon of the black hole, right? That's not within the event horizon of the black hole. Nothing escapes from within the event horizon except Hawking radiation. All right, y'all. I am going to end the live stream here. I need to go grab a bite to eat, then I have a doctor's appointment. But thank you guys so much for being here. Remember, if you want to join the Discord server, and if you're 18 plus, it's discord.gg/Dr. Blitz, Dr. Blitz. So make sure to go do that if that's the kind of thing you're interested in. Also, consider becoming a member on YouTube or on Patreon. It's like $4 or $5 a month, and it gives you access to emojis and debate notes. So until then, I will see you guys tomorrow for some more Ask a Physicist. Make sure to join the Discord and feel free to ask me questions there. Take care, everybody.